Hey, welcome to the lesson on Pythagorean Theorem. How can we use the distance formula to find the Pythagorean Theorem? So we're going to, by the end of the lesson, you should be able to review the distance formula and then use the distance formula to understand Pythagorean Theorem. So let's just review the distance formula one more time. D equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now suppose we have 2 points. Let's say negative 2, 1, which is right here, and 1, 5, which is right here. Now what the distance formula is doing is it's finding the absolute value by squaring and then square rooting the sum. It's finding the positive value of the distance between the x's and the distance between the y's. So here, from here to here, we have x2, right? This is our x2 coordinate. x2 minus, or sorry, it's actually x1 minus, so sorry, I messed up. But x1 minus x2, that's going to give me this distance. Okay? Now if we do y1, which is this distance here, y1, and y2, we're going to get this distance here. And now you might say, well, what if one's negative and so and so? Well, that's why it's squared and then square rooted again. But if I look at this just a little closer, this is, so that's going to give me this length here. Well, that actually ties in a lot with Pythagorean Theorem. Notice how we have a right triangle. So this length, this hypotenuse, here, the length of that hypotenuse, so the distance between those 2 points, so the length of that segment is going to equal the square root of the length of this segment. Let's call that A, and let's call this B. And so we're going to have x1 minus x2 squared plus y2 minus y1 minus y2 squared. And so notice how, yes, we're squaring it, but then we are unsquaring, we're square rooting it. Now, we already said this is my x1, and then I go over to x2, so that's where I'm going to put A. So the length of side A is x1 minus x2, so I have A squared. The side of this, this side of the triangle here, we already said is y2 and y1, and so that distance there is the difference between the two, which I have here, so I'm going to put B there. And this side over here, I'm going to call that C. So the distance between those 2 points is the same as the side length of C. And if I square the right side to get rid of that radical, try to make it as clean as possible, I get C squared equals A squared plus B squared. And that's where the distance formula comes from. Pythagorean theorem is actually derived from the distance formula. And the Pythagorean theorem again is a squared plus b squared equals c squared. We finish out the this problem with the actual points. We have 5 minus 1 equals 4. 1 plus 2 equals 3. And so if we did 3 squared plus 4 squared, we would get 25. And then if we took the square root of that, our distance here should be 5. And that's all in the math right here, is that 5 minus 1 equals 4. 1 minus negative 2 is going to equal 3. So I get here, I square both of them, 16 plus 9 equals 25, and the square root of 5 would be c, or the length of my hypotenuse. How can we use the distance formula to find the Pythagorean theorem? Well, the distance formula essentially is the Pythagorean theorem, and that's how we got the Pythagorean theorem, and that's how we can use the distance formula to find a hypotenuse in a triangle and many, many other things. So go ahead and make sure you copy this down, make sure you have this in your notes, because you'll want to reference it during the upcoming assignments. Go ahead and get started on those assignments. As always, if you have any questions, feel free to reach out to me on BBIM, phone, email, whatever's easier for you. I am also in the Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. And if that doesn't work for you, there's always a teacher in there willing to help you out every school day from 9 to 3. Next lesson, we will be talking specifically about applying coordinate geometry and the 3 formulas we learned, and when to use which formula appropriately.